Hey everyone, I'm Hussein Younes, and this might be the last video you need to watch on MCPs. In the following minutes, I'm gonna explain what an MCP server is, and then we're gonna dive straight into the terminal and build some real-world use case with Gemini-CLI. So first, we're gonna dive into the user guide of MCPs, so the official one that was created by Claude. MCP stands for Model Context Protocol, an open source protocol that standardizes how applications actually interface with LLMs. So we can think of it as like an adapter between LLMs and external applications. So why it has been actually implemented to begin with. So before the creation of MCPs, what you would do is the following. You would have the large language model that only has the knowledge that is embedded in its model weights, and it doesn't have like an external knowledge or actions that it can perform on behalf of you. It cannot actually reach like to APIs, or it doesn't have like an external knowledge about the real world. So what you would do to actually give the model the knowledge about the real world, you would actually implement tools. So these tools would be the interface between the LLM and the APIs that you want to interface your LLM with. For example, you want to interface the LLM with Google Calendar, let's say. So you want actually the LLM to be retrieving the meetings that you have. You want it to create a meeting for you or schedule an event for you. Before MCPs, what you would need to do is to implement tools that do the integration or the interfacing between the Google Calendar and the LLM. How would you do that? You would, for example, take a framework like LangGraph, and you would basically integrate custom tool calls for the tool that you're using. And these tools that you built wouldn't actually be accessible for other people to use as well. So everyone would implement their own instance of the custom tools that integrates or interfaces the LLM with the external service like Google Calendar in our example. So the MCP protocol came to solve this problem by standardizing how applications actually interface or integrate with large language models. So now, instead of going and implementing your own custom tools, what you would do is that the organization that is responsible for that service would implement an official MCP server, and then you just like use the MCP servers into your MCP client. So why MCP? As I just explained, it's basically there is a growing list of pre-built integrations that LLMs can directly plug into. The flexibility to switch between LLMs and providers and vendors. So as I explained, the MCP protocol is model agnostic, LLM agnostic. All you need to do is that you need to implement an MCP client that's compatible with the MCP protocol that people can, after that, integrate and interface with. So here's how the architecture looks like. We have the MCP client or host, which basically implements the client side or the LLM side of the MCP that's going to interface with the MCP protocol. In today's video, we're going to be using the Gemini-CLI. So Gemini-CLI has a client, has an MCP client that can easily interface with the MCP protocol and MCP servers. And then we have the MCP protocol, which is what we're talking about, the standardized way of interfacing with the LLMs. And we have the servers. So the MCP servers act as the providers of the tools and actions and resources and prompts on behalf of the service that you're going to interface your LLM with. So in the calendar example, Google Calendar would implement an MCP server that's actually just integrates smoothly with all the actions and tools that Google Calendar provides, and then it enables the LLM to use these tools to perform actions that you would normally perform as a human or from an API call to the Google Calendar. So there are also here two types of data storage. There is the local data storage, like your files on your computer, and there is the remote service. So we have the host, the clients, the servers, the data storage, local data storage, and the remote services, which are the external system available over the internet through APIs that MCP servers can connect to. So now we have actually the big picture of how the MCP protocol works and the main components of it. Now we're gonna dive a little deeper on a real world use case. So we're going to be using, as I said, for the client, we're going to be using Gemini-CLI. For the server, we're going to be selecting some servers that already exist, some official implementation or some community implementations of some services that we can use. The first thing that we need is the Gemini-CLI, obviously, installed. So the way to install it is that you need just to run the npm install Gemini-CLI command. You just copy this command, and then you run just the Gemini command. After that, you're gonna have a few options on how to log in into the Gemini-CLI. The easiest way to do it is with your Google account. So you're just gonna log in with your Google account, and you're gonna have some credits for free. So these are up to 60 model requests per minute and 1,000 model requests per day using Gemini. So basically, these limits are generous and are more than enough for us to build our use case for the MCP server. So now we have Gemini. So I've already installed the Gemini CLI. The second thing that we need to do, we need to configure the Gemini CLI. So there are a lot of configuration settings in the settings.json file for the Gemini CLI. One of the configurations that we're going to be using in this video is the MCP servers. So for the MCP servers, there are some settings that we need to put in the settings.json file. And these are actually explained in detail in the MCP server.md file in the official repository of Gemini-CLI. So here first they explain you everything. They explain to you what an MCP server is and how Gemini-CLI implements the client side from the MCP protocol. So there are actually two main layers for how Gemini-CLI interfaces with an MCP server. The first thing is the discovery layer. After you have set the MCP servers in your settings.json file, what Gemini-CLI is going to do is going to iterate through the configured servers. So it's going to go through the servers in your settings.json file one by one. It's going to establish the connections based on the connection configurations that we're going to do in a moment. After that, it's going to fetch the tool definitions. So as I said, every MCP server defines some tools, resources, and prompts. So it's going to go through the tool definition. It's going to fetch the tool definitions, and then it's going to sanitize and validate. So it's going to go through the schema of these tool definitions, and it's going to see if it's compatible with the Gemini tool call API. After it has passed the validation, it's going to register the tools. So it's going to set a global tool registry and resolves any conflicts between like multiple tools. So this is the first layer. The second layer is the execution layer. So after Gemini-CLI have actually prepared the MCP servers that you have set up in the settings.json, after that is going to do the execution. So how the execution happens, first is going to handle the confirmation logic based on the server trust settings and user preferences. After that, it's going to manage the tool execution by calling the MCP server with the proper parameter. So every tool inside the MCP server has its own parameters. Whenever you ask Gemini-CLI to do something, it's going to first prepare the parameters to call the corresponding tool. Processes the responses after Gemini-CLI have created the parameters for the tool and actually have called the tool. It's then going to process the response, make sure it's correct, and also it's going to display to the user the result and put it in the LLM context, basically. After that, it's going to maintain the connection state and handles timeouts. So this is actually the tool important things that we need to understand. And after that, we can actually start setting up our server. So what we need is that we need the server name. We put the server name here under the MCP servers. And after that, we need the command, the arguments for the command to use for that MCP server and some environment variables if needed, the current working directory, timeout, and the trust that we just talked about. So now that we have actually understood what an MCP server is, we have our MCP client ready, which is the Gemini-CLI. Now we need to choose our MCP server. Now it's time to go to the official GitHub repository of the servers. We're going to be selecting our use case. So here we can see there are a lot of like MCP servers. There are some official integrations, official implementations, and there's also some community servers. So now some interesting use case for me would be, for example, to see what are the trends in the AI field. So I make my videos about AI agents, so I would like to see what trends are there. So usually how I do that, I go to ChatGPT and I ask it, but it would also be interesting to have some like an MCP that actually fetches X threads that are like trending about AI. Same goes for YouTube. It's going to be like really interesting to have that. So that's what I'm actually going to be configuring in today's video. Okay, so here are the MCP servers that I have chosen. I'm going to choose this for the Twitter MCP. For YouTube, I'm going to use the Zapier MCP server. So there's actually an easy way to just like create an MCP server with Zapier. So you just choose the client. Fortunately, they have the Gemini-CLI client here. And you just use the tool or the MCP server that you want to use. For this, I found the YouTube MCP server that actually has the functionality of retrieving a YouTube video. That's why I'm going to be using this one. So these are the two MCP servers that we're going to be using. So first, let's start with the Twitter, with the setup of the Twitter one. So API key. Okay, I don't know where to get the API key. Okay, so create a Twitter developer account and get your API key from the Twitter developer portal. So let's try to get the API key from there. Okay, so I have actually created a Twitter developer portal account, and I generated the API keys, and I actually already saved them in my environment file. So now here's the MCP server configuration. So what I'm going to do, I'm going to just copy this and I'm going to put it in the MCP on the server, the JSON. So the command is npx. The args are y and the Twitter MCP server. These are the arguments for the command, the API key. So my API key, I can do like this here. So x API key and x API secret and x access token secret. So now what we need to do, we have configured the MCP server in the settings.json file. That's actually all we need to do now. We just need now to run Gemini and just make sure the Gemini-CLI actually sees the MCP server that we've configured. I guess we missed the MCP servers header in the JSON file here, so I'm gonna just put it now. MCP servers, and I need just to put extra curly braces here, so that's all. Okay, so now let me change this to Twitter MCP server, and now I'm gonna just run Gemini. So now we run Gemini, and so we wait for it to basically launch. As we can see here, using one MCP server, so already we know that Gemini CLI have detected the MCP server. Now we can just list the servers with /MCP. And here it gives us the Twitter MCP server. So what we can do, it can search tweets and post tweets. So if you press Ctrl+T, you can see the details about every tool. So post a new tweet to Twitter, search for tweets in Twitter. So now what we're gonna do, we're gonna just ask Gemini to search for some tweets. Search for the latest AI related, AI agents related tweets. And hopefully it should use this method. So, okay, so as you can see here, it's trying to use search tweets from the Twitter MCP server. So Twitter MCP server, the tool search tweets, and it's asked for consent to use the tool because we have not set the trust flag. So this is recommended. So now allow once. Twitter API error, the request failed with the code. Okay, so the error was that I haven't actually used the correct API key name. So it was called X API secret key, but it should be instead API key secret. That's how I called it in the .env file. So now we should be able to just verify that we have the MCP /MCP. So we have the Twitter MCP server loaded, and now we just search for AI related for recent. Let's see, AI related tweets. So now it actually should attempt to use the search tweets tool from the Twitter MCP server, and now we allow. Let's see the, okay, so here are the posts. So actually, here's what happened here. So like, we got these like initial results. So we got like some 10 tweets, and the query was AI. There was no other filters about we said the recent. So there's no filter about the recency of the post, and the count is 10. And after that, have filtered the tweets, and it returned those like 3 tweets. So let's check this one. Let's check the tweets, this one, and the third is this one. So the first tweet was actually in 5th of July. So it's actually maybe giving the most recent tweets, which is good. So according to the Seattle Times, Microsoft laid off 15,000+ employees in 2025 to free up spending for AI. So this is actually kind of scary. So let's check the second one. When AI meets creativity. Okay, so it's about AI. For now, that's what we wanted to explore, and we've correctly we've successfully used the Twitter MCP server. So now let's go to the second one, which is the Zapier one. So let's go to the connect. So we need to connect the MCP server now. I'm gonna take this. I'm gonna just copy paste the MCP server basically, and I'm gonna put it here. So MCP. So now let's check MCP. Okay, I believe we need to just exit and enter it again. So Gemini, and let's see if the second MCP server is like now fetched. So it has actually failed to connect to the MCP server. So I just need to copy this, and I'm gonna just rotate it later. So let me just paste here, and now I think Gemini should be able to connect to it correctly. So let's see. So it's trusted. I don't like that a lot, but it's fine because it's just searching for YouTube videos, so that's fine. So now we got no errors here, and we can check the MCP command again, and we can do Ctrl+T, and here we have like the add tools, add new actions to your MCP provider, edit your existing MCP. Okay, search for videos using various criteria like keywords, channel, date, range. Okay, this is really good. So we can ask like for recent videos as well. Search for the top AI agent related videos, the top and most recent AI related videos that are trending or hot right now. So let's see. Search for the top and most recent. I think this part wasn't necessary. Okay, so YouTube find video, Zapier MCP server. So exactly. So the video definition high, instructions. Search for top and most recent. AI workflows. AI builds AI and automates all your work. That's great. Introducing no other AI agents built for life sciences. 19 AI news stories. Okay, so actually. It's fairly good results. Here's what we've done in this video. We've actually learned what an MCP server is. We have used the Gemini-CLI MCP client. We have configured it with two MCP servers, the Twitter MCP server and the Zapier MCP server with the YouTube tool or tools. And we have actually used those tools with Gemini-CLI. There are like countless MCP servers that you can use. And basically it gives you like superpowers with your LLMs accessing whatever you want for you. That's the main concept. I hope you liked the video. Thanks so much for watching. If you have any questions, leave it in the comments section. And thank you so much for your time. I'll see you in the next video. Bye bye.